Hello everyone. Today we will be installing Linux Gentoo on a Raspberry Pi. This will work on any of the Raspberry Pi 64-bit varieties. We have the Raspberry Pi 3B, 3B Plus, the Raspberry Pi 4, and the Raspberry Pi 5. This should work on as little as the 2 GB version, and I recently saw an announcement for a 16 GB Raspberry Pi 5. I don't have one of those. But this should work on any of these varieties, but the GUI, the GUI interface, Xorg and stuff will work a lot better on the Raspberry Pi 4 and 5. The Raspberry Pi 3, 3B, 3B Plus, you could probably set up swap, but you're going to run out of memory, and if you set up swap, you're going to be hitting your SD card. I would probably recommend against that, although the Raspberry Pi 3s work great for non-GUI type applications like IoT or headless or no monitor type applications where you're not actually have a monitor plugged into it and running stuff on it. For this, I would also recommend making sure you have a good power supply. A lot of odd bugs and stuff can happen. Crashes and stuff can happen with the bad power supply. So I would recommend a 3 amp power supply, probably more towards, I think the one that's recommended for the Raspberry Pi 4 that I've got here, is probably a 4 amp or a 5 amp. This one that I've got is a nice one. It's by a company called Physical Computing Lab. It is a 4 amp power supply. It has a nice switch on it. This other one that I have, I don't have a brand on it, but it's a 5.1 volt 3 amp supply. These are both USB-C. The USB-C, I know there were issues with the Raspberry Pi 4 using just a general USB-C adapter. It was not 100% USB-C compliant, and it had issues with certain USB-C adapters. That has hopefully been resolved. We have the Raspberry Pi 5, and hopefully all those problems have been worked out by then. But anyway, and the other thing I want to point out is make sure you have a good SD card for these. The 2 SD cards I usually are go-to for me for a lot of projects. If I don't need a super fast, super fancy SD card, I'll usually get this one right here. This is a SanDisk Ultra, 32 gigabyte. It has up to 100 megabyte per second, and I think this is read speed. But this works very well for a lot of IoT projects where you don't need a real fast read and write speed. The other go-to SD card that I use when I go for setting up a Raspberry Pi with a GUI application or something faster is this SanDisk Extreme Pro. 64 gigabyte seems like a good number. Read speeds up to 200, and this one actually has a write speed of 90 megabytes per second. This, I have not had any major problems with these SD cards, but also be aware that there is a write endurance to any SD card you buy, and there's only so many times you can write to these SD cards before you will wear them out and they'll not be writable anymore. So with that, let's switch over to the PC and take a look at how we're going to build this. I've tried to set up this build so that it is pretty much just a copy paste. So we're going to go to, first of all, we're going to download the guide. So I have a blog site set up that has this entire guide available for download. We're going to go to this address. I'll put the link in the video's description, and we'll open up the website. And down here, partially down, I have the guides, the text files for download. They're right here. So we download that file. And I do want to make a brief mention also. This project is kind of a continuation of the original project, and I have links to these in this text file. The original project started many years ago by a person called Sakaki that aimed to put Linux Gentoo on a Raspberry Pi 4, and this project is no longer maintained but has been carried on by another group maintaining this. So I recommend you check out these links. And this project is kind of a fork of the original Sakaki project, and I kind of developed this at the same time that this other group was developing theirs. So a lot of this stuff, you may see a lot of references or things remaining from the original Sakaki project. So with that, let's start preparing the SD card for the Raspberry Pi. So I am using the SanDisk. I'm using the 64 gigabyte SD card, and we're going to connect it to the PC. And the first thing we want to do is we're going to get the SD card device. We can do this by just doing ls/dev, or we can do a mount, and we can see where the SD card is. So in my case, this is SDC, and we want to make sure this is correct. Some other ways we can do this, we can do dmesg, DMESG, and down at the bottom of the printout, we can see that the device that was just connected up to the PC is SDC, and there's a little bit of information on it, so you know that this is correct. So we're going to set up an environment variable, SD card equals dev/SDC, and I will make one more mention about this. A lot of people familiar with Linux will know this, but SDC1 is the first partition. We do not want to reference that. So we will copy and paste this in here. We'll set the variable up. And now we're going to make a working directory for our downloads. All of the downloads for this thing, there's a few things that I'll point out during the video here that, for one, I have tried to make all this stuff available. Generally, Linux Gentoo is in continuous development, and the repositories and stuff always, there's a lot of version updates. I have kind of created a freeze frame of that, and I am making these files available so that everything kind of matches up and you get something working. I'll try to update this project every few months to reflect the latest things, but for the most part, I'm providing a lot of the stuff downloadable so that this can be reproduced over time. So do be aware of that. Also, I will mention this later on too. There are a few things I have not been able to resolve. One of them is Chromium, and I'll get to that when we actually get the system up and going. It does not quite work right. Right now we're preparing the SD card. So we have not quite connected up the Raspberry Pi. We're doing this on, you can probably do this on an Ubuntu system. A lot of the commands I have tried to make sure will work on most flavors of Linux. You should be able to do this. I'm using a Gentoo, this development computer PC that I'm working with. This is Linux Gentoo as well. But a lot of these commands should work on most Linux machines, maybe some on Mac. I have not tried this on Mac OS. So the next step is let's set up a working directory. You can set it up in your home if you'd like. I have a directory that I like to use for Raspberry Pi development, and that's what I am going to copy paste here. Feel free to change these two commands. And you want to be in the working directory because a lot of these commands that we are going to be executing are relevant to their relative commands. You need to be in the working directory for them to work properly. So there are a few downloads. I'm hosting these downloads on my development server, so hopefully these remain available for the duration of, well, as long as this project remains relevant. And I am also referencing the original place where I got these files. All these files are available open source from the original sources. I just kind of downloaded them and tried to cherry pick the necessary files and make easy to work with archives to kind of speed the process up, but feel free to grab the files yourself if you would like the latest versions. So with that, so the first thing we need when we install Gentoo, and a lot of people that have worked with Gentoo before know this, is we start off with what they call a stage 3 tarball. And this is basically a very basic functioning root file system that we need. So we need two things to get any type of Linux installation working. We need three things. We need the kernel. The kernel is what the computer boots up as it boots up. And then we need a root file system. And the root file system is the actual file system, like the partition on the hard disk where everything starts loading up. The kernel loads all the hardware, loads all the drivers, mounts the root file system, and continues execution from there. And then the third part is we need the kernel modules, and those are like drivers that are not built into the kernel itself, but are available as kind of extensions of the kernel that are loaded when needed. So we need those three things as a bare minimum. And then the Raspberry Pi has certain firmware files as well to support the hardware. And the firmware files are basically as a device driver loads. Sometimes it needs to program the device with the firmware. Some of these hardware devices these days, like some on the Raspberry Pi, do not have the software in them. They are programmed every time as the driver loads, and the driver kind of starts up the hardware. So you can kind of think of it that way. So let's grab the stage 3 tarball. These are also on the original Gentoo dist files website. This is the repository for Gentoo where all the source code is. If you don't know, Linux Gentoo is a build from source operating system. It is highly customizable. This is one of the reasons why I like it. And you can pretty much build with a few small exceptions. Everything on your operating system is built as you install it from source. So let's go ahead and grab this. I have provided a copy of the current, because I don't know how long this specific tarball is going to stay on here, because like I said, Gentoo Linux kind of evolves quickly over time. This will probably phase out very quickly, so I am providing a cache of it. I would, as far as my development here, that I do here, I have a local repository that I keep here, but it is very large in size and would take some resources to keep an active server going with all the files available to everybody. So at the bare minimum, I am providing I'm providing basically everything except the source repository for this project. And so with that, I'm going to use wget to grab these files quickly. Wget should work on most Linux distributions. If you don't have it, you can install it. If not, you could just, worst case scenario, you could use a web browser to download these files. And however that works, you can get them that way. So I'm just going to copy paste these in. And this is going to download the files into our working path that we're in right now. And this is, like I said before, this first one here, this is the tarball. This is the stage 3 tarball that is the root file system, the basic root file system that we will be working with. And then we will download this is a digest. This is just a hash of the file to confirm that it's correct. We can verify it. It's not necessary. We can verify it and kind of confirm that these two hashes line up correctly. They should both print out the same. Next, we're going to get the boot partition. Now, another thing that I did to make this install go quicker is I went ahead and pre-prepared the boot partition for the Raspberry Pi. And like I said, you can do this yourself. All the files are out there. They're available. They're open source. A lot of stuff is on the Raspberry Pi's website. This also includes the kernels. I did rebuild the kernel, and there's a reason for that. I needed to install a support for the BTRFS file system into the kernel. That's the file system, as opposed to, say, ext3 or ext4. I am going to go with the BTRFS file system. Of course, this can be changed if you do not want to go that direction. You can change it back to ext4. There are a couple places that you will have to watch to make sure you choose the right options. But the original GenPi64 project used BTRFS, So I would like to continue that, and I have not had any problems with it so far. So with that, let's download the original, I'm sorry, not original. Let's download the boot partition. And these are all tarballs. So when we get to mounting the SD card, we will set up the SD card and copy the necessary files into that SD card. So the next thing is we're going to grab the kernel modules. These are going to be copied into the root file system when we go to prepare that. We're going to grab the firmware. So like I talked about before, these are the firmware files to go with the hardware drivers for the Raspberry Pi devices. And then we have some firmware files that are specific to the Bluetooth. I know that this says non-free. I think it refers to a type of license agreement that they have. These are all publicly available. There are download links to the original GitHubs where I downloaded these from. And then we will download the kernel sources. And the reason to put the kernel sources on the Raspberry Pi is to assist the installer. So a lot of times when we install software, it will verify the kernel version and verify what options that are compiled into the kernel to kind of tailor the installation to match the kernel. So it's kind of a good thing to have the kernel sources available. They don't have to stay there. When we're done with this install, you can wipe this. It's not too much more space. I think it's around 500 megabytes or so, but we can clear those out when we're done if we don't want to keep them. So these will take just a minute to download. Okay, the tarball is 556 megabytes, which will probably expand to maybe a little over a gigabyte. So we'll find out. Now I'm also providing, although you absolutely do not need these, I'm providing the binary patch. So during our install, normally Gentoo installs from source and it compiles everything as it installs it. But in our case, in order to speed things up, I've actually done all the hard work here and pre-compiled everything. And I have uploaded the binary packages, and I have set up during our setting up of the Raspberry Pi, we're going to set it up to pull those binary packages down and install already compiled stuff. And you can turn that off if you'd like, but this took several days to compile. I mean, Chromium itself took 3 days on a Raspberry Pi 5. But I'm providing these files here if you need them. The binary packages, like I said, will download automatically as they are needed, but they're available here as an archive if you want to grab them. And then I'm also providing, like I said, I couldn't make the entire Gentoo source tree available at the time that I froze it, and I think that's January 10th, 2025 is when I froze it. But these are available. Let's see, January. Oh, these were built on January 21st. I think it's from January 10th though. So these are the sources, and if you ever need the sources and they're no longer available online, you can grab the sources from here. But like I said, we'll be working with binary packages, but they are here if you need them. And once we're done here, we're just going to do an ls-l and make sure that we grabbed all of our files necessary. We should have something similar to this on here. We should have all these files. And now we're going to start working with the SD card. So I know I'm probably going a little bit fast. I'd like to try to get through this as quickly as I can without making too long of a video. Feel free to stop the video, rewind it, skip through it if you'd like. Another mention I'd like to make is I will make this complete. I will make the final SD card image available for download. So if you don't want to go through all of this this process, this is going to take the actual emerge and installation of software took about an hour, and so you could probably allot an hour and a half or so for this entire process. If you don't want to go through that, I'm going to provide the final image for the SD card and make that available for download. And you can just download that into your SD card, just like you download the Raspberry and the Raspberry Pi OS. Just copy it on the SD card, pop it in your Raspberry Pi, turn it on, and it should in theory just work. So anyway, let's continue on with the SD card creation. So we have set up the path for the SD card in this variable SD card, and just to make sure that this is right, we're going to verify that SD card is pointing to dev SDC, and it is. If this is wrong, you could do some very bad stuff if it's pointing to the wrong partition, or wrong hard disk. So the next thing we're going to do is we're going to repartition the SD card, and we need to make a boot partition. I don't know about all of the Raspberry Pis these days. The first Raspberry Pis that came out couldn't read anything but a fat partition for booting. I don't know if that has changed lately with the later Raspberry Pis. So the first partition, we need a boot partition, and then that boot partition has the kernel on it. The kernel loads, the kernel has ext4 or BTRFS support, and that loads the second, that mounts the second partition, which is a root file system, and continues booting from there. So we're just going to execute this as an entire block. This will create a 512 megabyte boot partition, and then allocate the rest of the space. It says ext4 on here, but when we format it, it's going to go to a BTRFS file system. So these are going to require root privilege, so these are going to be sudoed. So if you have a password set up, if I remember my password, okay. And then we're going to set the partition UUID, and this is necessary because when we boot, the kernel will actually mount the root file system not based on the device like dev-SDA, dev-SDB, dev-SDA1, SDB1, etc. It will mount it based on the partition UUID. So we are going to fix the UUID to this number here, which is 6C586E13. And there are two references to this in the project. I'll show you where those are when we get to it. We are going to format the two partitions. And the first partition is formatted vfat, which is FAT32. And then we're going to create a BTRFS file system on the second partition. And we're going to label them bootfs and rootfs. I don't think they need a label, but it doesn't hurt to put one on. And what do we get? SDC. Okay, I need to fix one thing. My motherboard is a little bit glitchy, so let me back up for 1 second and insert that SD card in SDC. Okay, we missed a step. All right. We missed a step that was important. Did I not dismount these? I did not dismount them. Okay. Make sure you dismount these partitions before you do this. And that's one thing that I skipped. So go up here, make sure that you select these. Make sure that you do an unmount on both partitions if they exist. You can do a mount to be sure that the file system is not mounted. And then just to be sure that everything went right, go ahead and execute these two commands again. Okay, and then we'll do the format. Okay, the format went through correctly this time. We are going to create mount points. Now, another unique thing with Linux that a lot of Linux people know is that you can mount a file system. Basically, everything in Linux is a file, can be treated as a file. You can mount the partition wherever you want in the file system. So we're going to mount it under bootfs and rootfs. And if we look, ls-l, we just created those two folders. And when we execute these two commands here, these are going to mount the SD card in those two locations. And if we do a mount, we can actually see that they are mounted now. SDC1, SDC2. And then we're going to copy the boot files. So this is one of the archives that we downloaded. Now we're going to create the boot partition, or actually we're going to populate the boot partition on the SD card. So I'll execute this command. And then we're going to copy in what is commonly called the stage 3 tarball. And this is the base root file system for a fresh Gentoo install. And this is going to be copied into the root fs. Okay, I have another glitch here. Okay. I need to put that SD card in a different USB slot. I've got some issues, some hardware issues with this motherboard. So let me back up for a second. Okay. SDC. Okay. Now we're back on track, I think. So let's re-execute these commands. You should not have to do this. I've got some issues. So I built this 14900KS system a while back, water-cooled thing. I'll have to make another video on it. But there's videos in the on the channel here that outline that. And I've had some issues with the USB ports under Linux, the USB 3.2 or whatever they are. Let's go ahead and execute our commands again. And this time I have it plugged into a USB port that hopefully will not have issues with that micro SD card. And mount points are created, so let's mount the partitions. Okay. Copy in the boot partition. We're going to copy in the stage 3 tarball. This will take a few seconds to copy. Then after this installs, like I talked about before, we need a few other things. We need the kernel modules. The kernel itself is inside this, boot archive that we just copied in. And then that kernel will also need these modules. These modules are version matched. They're built at the same time as the kernel does. So if you do upgrade or replace the kernel, you'll have to upgrade and replace the kernel modules that match that version as well for everything to work properly. Okay, those are copied in. So let's copy in the kernel modules, and we will have to create the lib modules folder, which is where the modules live. That's where the kernel looks for them. And we're going to copy the firmware in. And the blue, let's see, copy that in, and I have a typo on here, extract the Z firmware. I'll upload a correction to that. And then we're going to put the kernel sources on here. This is going to take several minutes to copy in. It's quite large, but it will help make the installation go smoother. So that will take just a minute to get ready. And while that is copying, let's start setting up the hardware for this. So let's clear off our workspace. This, I do have a case for this Raspberry Pi also. And you don't have to have a case, but I find the cases nice. They provide a little more, well, a little more protection for the Raspberry Pi to protect it from drop or damage. And then I would not necessary, I would put a heat sink on it, and it's nice to have a fan. You can either get a fan like this, which is just the fan module. It's an active cooler, or these, like this case that I got, this Raspberry Pi case. This has a fan built into it. And there's the Raspberry 5 actually provides a fan connector now, which is nice. So we just connect that up. And let's check the progress of our kernel. Sources are still copying. And this does have a cover. We're going to leave the cover off for this. So like I said, we're going with this Extreme Pro SD card. This is what's currently attached to the machine that we're copying files onto. And we'll go with the 4 amp power supply as well, just so there are no issues. And then for this, Wi-Fi will not initially work. It can be set up, but it's a little bit tricky to set up without the GUI. So we're going to use a wired Ethernet connection. And I'll connect in here. We have our micro HDMI plug, which will plug into here. And I have a keyboard and mouse. You do not have to use a Raspberry Pi keyboard and mouse. I acquired these a while back because they were just handy to have, and they're kind of cool looking. So we'll plug that in. We will not use the keyboard and mouse that much, just for the final testing, but we will need it for a small portion of the setup. And then we have our power supply. Now this power supply is nice. It has a switch on it. So we will plug that in, and I will get that power supply connected up in a minute. Okay, back to our SD card preparation. So we're going to create a symbolic link to the Linux sources. And this is where emerged the package manager checks for this stuff, checks for the Linux sources under user source Linux. So we created a symbolic link to that. And right now we do need to set a root password, because right now there is no root password for this file system, and if we just start it up right now, we will not be able to log into it. So the way we're going to do this is we are going to generate the hash. So passwords in Linux are stored in hashes. There are multiple types of hashes available, but I'm going to use a more secure one that will be kind of hash is it? Is it a 512? Anyway, this is a better hash than, well, let's see. You can kind of see here what type of hash we're generating. OpenSSL brand, OpenSSL PSW. So if we just type this in, we can kind of get a read sudo on that. Do I? Yeah, SHA-512 based password algorithm. So this is the hash we're going to generate. So in order to do this, I've kind of got an automated thing set up here where you can just fill in this blank with what password that you want. So say you want the password to be root, you'll just type root in here, and when you run this, it's going to generate a password salt, which I'm just going to have OpenSSL generate a random salt for us. And then we copy and paste this block in, and it will spit out this big long string. This is our hashed password, and this is what we will be putting in where the passwords are stored in Linux, which is under etc shadow. And we can do this two ways. I have an automated thing set up to automatically do that replacement in the file, but we're going to do it by hand just so we can see the detail. So we're going to edit this file, and these are the current users that exist in our Raspberry Pi system. So the only one that really has any significance is this root one. So I am using vim, and this is just a basic text editor. You could probably edit these files another way. Nano is another popular editor. Oh, I don't have Nano installed. We will see Nano on the Raspberry Pi when we get to it. So vim can be a little bit tricky to use. So the way that you use it, so when you initially enter vim, you're in a kind of a command mode here. We can't actually type stuff yet. So if you press the letter I on the keyboard, you'll notice that we are now in insert mode, and we can type stuff and edit stuff in the file. So we're going to edit this file, and we're going to copy paste this string. It actually, I did not copy that string, so we need to back out. So in order to quit, we need to hit escape to get out of insert mode, back into command mode. We type a colon on the keyboard, and then down here we have a command prompt entry. So Q is quit. So we can quit, but we'll also notice that the thing warns us that there was no write since last year. It won't allow us to quit without writing the changes, but we're going to override that and quit without saving. So we're going to colon Q exclamation point to override it, and it will exit us out. So we're going to copy this hash. We're going to go back into VI. We're going to use the arrow keys to go over to where we want to edit. Do I, backspace, paste. We're going to hit escape to get back into command mode, colon, W for write, Q for quit, enter. Our root password is now set as root. We will disable the root password later on, but we need it to initially log into the Raspberry Pi to finish the setup. Now, if you would like to, you can change the keyboard layout. I think it's defaulted to US. We can take a look. If you'd like to look at what key maps are available, you could take a look at these listings. And so the file that we will edit is etc conf.d key maps. And if you were to edit this, right now it's set up to the US key map. We will leave this as it is. In some people's cases, like for some keyboards that I use JP106, so we could change that here. But like I said, we're going to leave that as US. So we're going to quit out of here. We don't need to change anything. And then we're going to do some setup for the Ethernet adapter. For the Ethernet adapter, we need to be able to start it up, so we need to create a symbolic link for it. A lot of people that have used the older Linuxes that work off OpenRC, which as opposed to systemd, which is now getting more popular. I still use the OpenRC system. I think it's more simple and easier to use. But we need to set up a symbolic link for our network interface. So we're going to go to the initd folder. And if we look in here, you'll see various different startup scripts. So in order to start up the Ethernet adapter, we are going to create a symbolic link to net.low, and we're going to call the symbolic link net.end0. And this is the name that the adapter will be when it comes up on the Raspberry Pi. So before the naming convention changed, there was always like ETH0 and stuff, but lately it has been changed. Let's see. Let's do an LSL here. Okay, so we can see we've created a symbolic link. So we're going to exit back out to our working directory. And now we need to set the host name. I think you need to set the host name to something for a lot of the stuff, including the Xorg, the GUI to work. So we'll set that. And now we're going to set up what we call the Portage tree. And the Portage tree is basically a catalog of the software available to download. And we need to let the Raspberry Pi know where to get that catalog from, because it does not have the catalog currently installed. Like I said, this is the stage 3 tarball that we installed is just a base tarball. There's nothing in it. So we are going to open up this file for editing, which is etc portage repos config and gentoo.conf. This is going to set up the repo configuration for the Gentoo repo. And in the case of this guide, I'm providing the URL here for the actual official Gentoo Portage tree. And you could switch over to this after we're done if you like. But when you go to install software, it may or may not break things. So until we're done and we have a fully working system, I would leave this as it is. This is pulling the Portage. I am providing a freeze frame of the Portage system, a snapshot that I took on the 15th of January of this year, 2025. And that's where I have everything set up to work with this guide. So we need to make one more reference. So the Portage tree that I got is just that I've provided here is just a snapshot of the official Portage tree on the 15th of this month. I have changed nothing in it. It is identical. But like I said, that Portage tree evolves over time and will be different tomorrow than it is today. It could be different in 1 hour. Okay, so the next one, we have one more Portage tree to set up. We have the GenPi64 Portage tree. And the original one was made by Sakaki, if you remember in the guide, which is no longer maintained. So on this, the important things on this Gentoo, there are still some remnants of this in here. The maintainer stuff, I haven't tweaked that. But this includes the profile that is going to instruct the emerge which packages to emerge in, and it basically set the profile up. And I've got various things set up in there to automatically do some things for us, and I'll explain a little bit more as we get down to that part. A lot of things in Gentoo are configured by what they call use flags and accept keywords and stuff like that. And a lot of that stuff I have set up in that profile to do that automatically. Okay, and then we're going to edit a file called make.config. And make.config is basically a global compile options for installation. So we're going to edit that file, and this is what's currently in there. Now another thing I didn't mention, VIM, you can press O to insert a new line. We could go to the end of this line and press enter, but another shortcut is when we're in command mode here. You can hit escape multiple times if you want to make sure you're in command mode. Press O and it'll insert a new line, and we're automatically in insert mode, so we'll press enter one more time. And we'll copy paste the stuff in between this begin and end here. And when I'm copy pasting, another trick you can do in Linux is if you press the middle mouse button, it'll copy paste what you have currently selected without passing it through the clipboard. And that's something I use often. Then same thing here, we hit escape to get in command mode, :WQ, enter. Okay, now we need to set up SSH so that we can log in. And a lot of this configuration stuff, we can boot the Raspberry Pi and get it going, but we're still going to have to copy paste a bunch of commands into the Raspberry Pi after we get it started up. So we're going to do that in an SSH session to make things a lot easier on ourselves. So we're going to, for the moment being, we're going to allow the root account to log into SSH, which is probably not, we'll take this out. This is not something that you probably want to do in a production system. We will take that out when we're done. We're going to permit root login. We're going to tell it yes. We're going to escape :WQ to save and exit out of there. And then there is something specific to the Raspberry Pi where you will get a respawn error for one of the serial ports on the Raspberry Pi. So we're going to disable that. So we're going to put so we're going to hit I to insert, type a pound in front of that to disable that line, escape, :WQ. And next we're going to edit the fstab. Fstab basically tells the system what partitions and what disks to mount at startup. And what we would like to do, the root partition mounts automatically. We don't need to worry about that. But what we would like to do is have the boot partition mount as /boot so that we have easy access to the boot files. So we're going to copy paste that in, and you'll notice the part UUID. This needs to match that number that we set up earlier when we partitioned the micro SD card. And then it has a -01 to indicate the first partition. So this should match what is there. If it doesn't, this will not mount correctly. If you do edit your part UUID, make sure you change that. That's one place to change it. The next place that the partition UUID is in is the command-line.txt. Those that have worked with the Raspberry Pis a lot are familiar with this cmdline.txt file. This allows you to set options for when the kernel loads. And one of those options is to let the kernel know where your root file system is. So during my development, I used a USB hard disk a lot, so that's why this is in here. So we're going to edit this. Actually, we're going to remove the entire line. So another trick in VIM is if you press D twice, DD, it will delete an entire line. Then we'll press O to, so we'll press I to insert, and we're just going to copy paste this line in. And we'll notice that the part UUID is our partition ID -02, which is the second partition. We have our root file system type set to BTRFS. If you happen to use ext4, you'll need to change this root file system type to ext4. And root delay is 0. When I used an external USB hard disk, I had root delay set to 10 seconds so that it gave the hard disk, I have a spinning hard disk, gave the hard disk time to spin up before the kernel attempted to mount it and failed. If you have these options wrong, especially this root partition, this root option here, the kernel will, well, you'll get a kernel panic when it attempts to mount the root partition, and the system will just kind of sit there. Okay, these we don't need to do. I talked about this before, about the bin packages and the distribution source code. And we are done with the initial preparation of the SD card. So we're going to unmount it. And then we're going to remove the mount folders that we created. So if you look, those are clean. So I'm going to disconnect the SD card now. And we're going to put the SD card in the Raspberry Pi. I dropped it, hold on. Okay, this is also a handy thing to have, this USB to micro SD adapter. I don't think I mentioned it at the beginning of the video. So this is what I use to write the SD cards. Some laptops may have an SD card slot in it. You can use that as well. So we're going to put this in the Raspberry Pi. Now I'm going to set up the Raspberry Pi to capture. Hopefully I can capture the Raspberry Pi screen. So I'm going to connect the Raspberry Pi up to capture. Okay, and I need to plug it in as well. Okay, as soon as I can, I'm going to start the capture on the Raspberry Pi. See, as soon as I get a screen to do that. Raspberry Pi is on. So this is what our initial startup screen looks like on the Raspberry Pi. So we didn't actually see that much. So the first thing we need to do when we start up the Raspberry Pi, so we're going to log in with root, password root, and we should be able to log in. And we need to start up two things on the Raspberry Pi, and then we'll switch back over to our other computer so we can copy paste. We need to start up the network adapter, because if you notice the network cable is connected, but the network is not started. So in order to do this, we need to do a /etc/init.d/net.eth/end0. And the way we can see this, if we go to ifconfig, we'll notice that the network adapter is called end0. And we can also see the start, we created the startup script, and we'll notice that WLAN0 shows up too, but we don't have things like, we don't have the software on the Raspberry Pi yet to do the SSID username and password login. So we're going to start up the network adapter, which is /etc/init.d end0 start net.end0. Notice it does have an IP address. It did seem to grab an IP address, but we'll start. Okay. And now we need to start up SSH so that we can connect to it. So do a /etc/init.d/sshd start. Okay, SSH is now working. Our Raspberry Pi, we're going to leave the Raspberry Pi just as it is. So I'm going to connect the video capture back up to the other PC. Hey, sorry guys, this video has gotten a little bit longer than I thought. There is just too much to fit in one video. So I'm going to split this into a two-part video. In the second part video, we will finish up the remaining Raspberry Pi setup during the SSH session. And well, so with that, I will thank all you guys for watching, and we will see you over on the part 2 video. See you there.